Have you ever pondered over the concept of nothing? What does nothing truly mean? These are questions that may seem simple at first glance, but are they really? When we think of nothing, we often imagine an empty space, a void, a total absence of anything. Yet this idea of nothing is far more complex and intriguing than it initially appears. For centuries, humans have been fascinated, perplexed, and even intimidated by this concept. It's not just about the absence of something. It's about the existence of a concept that holds its own significance and weight. In our everyday lives, we often use nothing to express a lack of something. We say, "There's nothing in the fridge," or "I have nothing to wear." But what we're really saying is that there's an absence of what we want or need. But nothing is not just an absence. It's a concept that holds a certain level of profundity, one that has stumped thinkers, philosophers, and scientists alike. In the realms of philosophy and science, nothing takes on a whole new dimension. It's no longer just an absence, but a puzzling, enigmatic idea that challenges our understanding of existence and reality. It's a concept that has been the subject of intense debate and discussion, one that has sparked countless theories and interpretations. How can nothing exist? How can it hold significance? These are questions that have baffled the greatest minds throughout history. From the ancient philosophers who contemplated the mysteries of the universe, to the modern scientists who delve into the realms of quantum physics and cosmology, many have grappled with the concept of nothing. In the following scenes, we'll explore the intriguing journey of nothing throughout history. We'll delve into the thoughts and theories of those who've attempted to unravel its mysteries. We'll traverse the corridors of time, from ancient philosophies to the scientific revolution, all the way to modern science. From ancient philosophers to modern scientists, many have grappled with the concept of nothing. Let's delve into their thoughts and theories. Ancient philosophers had their own interpretations of nothing. Let's take a journey back in time and explore these fascinating ideas. In the cradle of Western philosophy, ancient Greece, the idea of nothing was a topic of intense debate. Parmenides, a pre-Socratic philosopher, argued that nothing does not exist. He reasoned that for something not to exist, it would have to be conceivable, and if it's conceivable, it exists in some form. Thus, in Parmenides' view, nothing was a paradox, an impossibility. On the other hand, Aristotle, one of the most influential thinkers of all time, had a different perspective. He believed that nothing, or void, exists potentially. In his work, Physics, he discussed the possibility of a vacuum, a space devoid of matter, hence, nothing. However, Aristotle argued against the actual existence of such a vacuum, stating that nature abhors a vacuum. Yet, his mention of the potential for nothing opened doors for further inquiry. Moving eastward, the Buddhist concept of emptiness or sunyata offers a different perspective on nothing. Unlike the Western notion of nothing as an absence or void, emptiness in Buddhism is not about the non-existence of things, but rather it's about understanding the interdependent nature of all things. It's a philosophical tool to deconstruct the illusion of inherent existence, suggesting that all things exist in relation to each other. So, emptiness isn't about nothing in the literal sense, but about everything in a relational sense. These ancient philosophies laid the groundwork for further exploration of the concept of nothing. But as science evolved, so did our understanding of nothing. The scientific revolution brought a new perspective on nothing. As the Renaissance gave way to the Age of Enlightenment, a seismic shift occurred in our understanding of the world. The scientific revolution, a period of intense discovery and questioning, overturned centuries-old beliefs and fundamentally altered our perception of nothing. Imagine the astonishment when the first microscope revealed a world teeming with life in what was previously considered empty spaces. This was a radical departure from ancient perceptions of nothingness. Minute organisms, invisible to the naked eye, were found to inhabit droplets of water, particles of dust, even the air we breathe. Suddenly, what was once nothing became a bustling metropolis of microscopic life. This revelation brought a stark realization. Our senses, limited as they are, can often deceive us into perceiving nothing, where there is indeed something. Parallel to these biological discoveries, the concept of the vacuum emerged in physics. In the simplest terms, a vacuum is a space devoid of matter. However, the scientific revolution taught us that even in these seemingly empty spaces there is activity. Invisible forces like gravity and electromagnetism operate in these vacuums, proving that they are not as empty as they might initially appear. The notion of nothing was thus radically transformed. No longer was it a mere philosophical concept, a puzzle for thinkers to ponder upon. Nothing was now a scientific entity, a subject of empirical study and exploration. It became a challenge for scientists to delve into, to uncover the hidden mysteries of the universe. This shift in perspective, brought about by the scientific revolution, changed not just our understanding of nothing, but also the course of human knowledge and discovery. It made us question our assumptions, pushed us to explore the unseen, and ultimately led to breakthroughs that have shaped our modern world. With the advent of modern science, nothing was no longer just a philosophical concept. It became a scientific one too. In the realm of modern science, nothing takes on a whole new meaning. It's not just an absence or void, but a stage where nature's most intriguing performances take place. Let's dive into the quantum world, where nothing is a teeming sea of virtual particles. These particles, too tiny for us to see, are constantly popping in and out of existence. This might sound like magic, but it's actually a consequence of Heisenberg's uncertainty principle, one of the cornerstones of quantum mechanics. This principle allows for particles and antiparticles to briefly form and then annihilate each other, all within the so-called empty space. So, in quantum physics, nothing is never truly nothing. It's a ceaseless dance of creation and destruction. But what about empty space in the cosmos? Is it really empty? Well, the answer is a resounding no. The universe's empty space is actually filled with dark matter and dark energy, mysterious entities that we can't see but whose effects we can observe. Dark matter is believed to provide the gravitational glue that holds galaxies together, and dark energy, it's thought, is responsible for the accelerating expansion of the universe. So even the vast, seemingly empty reaches of space are full of unseen activity. In addition, the empty space inside atoms, which make up everything we see around us, is also not truly empty. It's filled with fields of energy, and the particles we know, electrons, protons, neutrons, are just excitations of these fields. So, in the context of modern science, nothing is a misnomer. It's not an absence, but a whirlwind of activity, a hotbed of potential, a wellspring of creation. It's a place where particles play hide-and-seek in the quantum foam, where dark matter and dark energy shape the cosmos, and where energy fields give rise to the very fabric of reality. The concept of nothing in science is far from empty. It's a buzzing, dynamic, and fascinating entity. So nothing is not as simple as it seems. It holds a power and mystery that continues to fascinate us. In the vast expanse of our universe, nothing is a concept that's far from empty. In fact, it's filled with endless potential for new scientific discoveries. Let's consider the concept of nothing in the realm of quantum physics. Quantum mechanics, the science of the very small, has taught us that nothing is buzzing with activity. It's a field of fluctuating energy, where particles and antiparticles are constantly being created and annihilated. This nothing is a bubbling, boiling brew of virtual particles that pop in and out of existence in a timescale so short that we can't directly observe them. These virtual particles, born out of nothing, can have profound effects on the universe around us. They can influence the properties of particles we can observe, like electrons. They can even affect the energy levels of atoms and the behavior of fields. The study of nothing, therefore, is not just a philosophical or theoretical exercise, but a tangible, practical one with real-world implications. The power of nothing extends beyond the realm of quantum mechanics. In cosmology, nothing plays a key role in our understanding of the universe's origins and its ultimate fate. The Big Bang theory, for instance, posits that our universe sprang into existence from a state of nothingness. The study of this nothingness can help us understand the conditions that led to the birth of our universe, and perhaps even shed light on whether other universes exist. Nothing also has the potential to unlock mysteries in other fields of science. In biology, for instance, the concept of nothing is crucial in understanding the process of cell division, where a cell divides into two, effectively creating something from nothing. So, in the grand scheme of things, nothing is a scientific powerhouse. It's a concept that's central to our understanding of the universe and its workings. It's an idea that's at the heart of many scientific theories and discoveries. Nothing, it seems, is truly something, and that something has the potential to unlock the secrets of our universe.